Can you give me? Yeah, hi everyone. This is the group assignment of CS 591, and my group members are Ayodhya and Girdhar. And coming to the artificial intelligence, yeah, coming to artificial intelligence, um, basically it is a designing and the training computer program related to the machine like a human perform tasks, and the humans naturally can do with the artificial intelligence. And the machine learning is a method of teaching computer to perform specific tasks according to the algorithms, and there are many languages in it, and basically we use the C++, Java according to it. And the computing machinery, and coming to the computing machinery and intelligence, it is a seminal paper written by Alan Turing on the topic of artificial intelligence, which was published in 1950. And he generally raised a question about the machines, that can machines think, and we need to get the definitions, brief definitions of machine and the think. How can we discuss about it and the clearly defined in our words. And next, coming to the definition of machine. Basically it is a physical system that these activities using the machines are handled and modulated by the humans. So not the machines can perform as its own, but the human support is required for it also. But the human support. And coming to the think, for everything we need to think in mind and take the decisions in a correct order. Then only we can make the task successful. And coming to the next topic of it is digital computers. A digital computer plays a key role in the computer systems. Humans are operating these digital computers using the technologies updating day by day. And in the digital computers also there are types of digital computers, microcomputers and mini computer and mainframe computer and supercomputer and smartphone. And microcomputer, coming to the microcomputer, it's simply low cost and easily available. And the devices used in these is the microprocessors, input unit and the storage unit and the control processing unit. And in this also the types of microcomputers are there: desktop computer or personal computer, as well as the notebook computers or laptop and netbook. Nowadays the tablet is using more compared to these all, because the technology has been updating day by day. And coming to the mainframe computers, generally require attention and kept in a controlled atmosphere, compared to the general computers. And the mainframe computers are somewhat updated versions, and the tasking of these are generally high compared to the um, general computers we use. And the examples for these is it's IBM Linux one. And coming to the supercomputers, supercomputers operate very fast and have the multiple processors. There are very few of these machines in extension due to their cost. And the processors and the multiple processors have been using these. And in the scientific applications also, supercomputers had played a very key role in the scientific options also. All the advances like multi-core processors and GPUs, general processing, graphics processing units, have enabled powerful machines for these also computers. And yeah, and I'm continuing with and in these also, the main thing is we need to store something, and after the storing we need to execute using the execution unit. And the last thing is we need to control. For everything we need to have these three steps. Only by using these three steps only we need to perform a task successfully. And the data is to be stored clearly. and after that it gives to the execution one, so that if we give the right person or the right way of execution only, the task will complete in a successful way. And we need to control all these. So when only after controlling these three only, we can be able to get a document in a file or in a complete manner.
Thank you, Nandu. I'm going to continue here onwards. Recently, there are multiple languages built to train the machines. So today we will be discussing machine learning in Python. Even though there are wide range of machine learning languages, Python became most popular. The reason is it has compatible with multiple mechanisms, and also it has a lot of libraries, and that is open source and available for everybody to use and free. So Python is high-level interpreted programming language, and it is very easy to learn. Python compiler and interpreter, we call that CPython compiler. It's usually compile code in a single thread. So this will be a problem that whenever we are dealing with the huge data sets. So they have introduced PyPy, which use the just-in-time compiler. So that way we can split the task into multiple threads. Compared to CPython compiler, PyPy can run program faster. According to the papers, it says it's almost 4 times faster than the regular Python compiler. Python can be used to train the machine whenever we are doing deep learning. There are many libraries that are built and support for Python. For example, Pandas, NumPy, Fortran, and there are many more other libraries. Optimizing the Python performance. So CPython interpreter is not using advanced technology of the modern machines, even though the machines are capable of doing things in effective manner, but regular Python compiler is not up to date with that one. So they have introduced different libraries to help with the performance. For example, the Intel math kernel libraries provided portability. So same code, using that same code can be run in a different architectures with a different infrastructure. And even though it's moved to a different machine, it will be performing the exactly same way. Algorithms operations on a set of values, we usually call that as vectorization. So this that means it supplies single instructions to multiple data points. Libraries such as MapReduce, Spark, and Dask are usually used for parallel data point accesses. Next, we come to classic machine learning. Non-deep learning based machine learning is usually known as classic machine learning. This includes decision trees, random forest classification, and support vector machines. Most classic machine learning is used to structure data within a tabular form. So in our left side in this diagram, you will be seeing a sample program that has been used sklearn. We in day-to-day basis we call it sklearn, and using that library, we have used the iris dataset to make some predictions. So the diagram B will show the pipeline of the training the machine. Obviously, with everything else, there are some challenges when we dealing with the data modeling. Class imbalance can make prediction bias when we modeling the algorithm, especially when we are working with the real world data set. Usually sklearn perform the uniform splitting. So especially when we use the train test split function, data set will be distributed unevenly. So that way we will be getting overfitting or underfitting scenarios. To avoid that, sklearn also provide satisfied sampling. So that way we can split our data samples into X trains and Y train without having any biased data set. Combination of a different machine learning algorithm can be used together to increase model of the performance and stability. This we usually call it ensemble technology. Random forest did one example. So as we know, each individual decision trees are clubbed together to get the final decision that we call the random forest classification. Scalable distributed machine learning is when we came to scalable distributed machine learning, scikit-learn focus on small to medium data sets. So when we are dealing with the large scale data set, we introduced DuskML. DuskML use multiprocessing, so which means that we can compute algorithm that can be distributed over multiple nodes in a same computer. And also it has the hyperparameter optimization, which we called as HPO library, and it also supports the sklearn APIs. PyPark is introduced by Apache. Also another API that enables users to train advanced data model easily. And Spark is written in a Scala language. Both Dask and this Spark message parsing interfaces we call as MPIs. This used to write distributed algorithm. Also memory location can be passed from one machine to another. Here in the automatic machine learning, next topic is automatic machine learning. Usually when we teaching a machine to perform a task, we have to go through with multiple steps that explained in the diagram A. Like basically we before we train the data set, we have to do the feature engineering, model selection, and hyperparameter optimization, and then finally we do the model evaluation. So when we in the automatic machine learning, what we do is we club multiple operations into one single module, so that way we can execute our module really fast and efficient manner. GPUs we call as graphic processing units. Recently accelerate the data science because GPUs actually introduced like way back, but 1999 CUDA was introduced, and with that was the first effective general purpose GPU. Even when efficient libraries improve the performance of the models, CPU has a major role, because if it cannot cope up with the all the functionality we build, then our program will not function as we expected. So Rapids was introduced to support a GPU accelerated Python tool. Its core libraries include pandas and scikit-learn, and there were like NetworkX libraries also. Mostly used options in GPU was like cuFT, CuPy, and TensorFlow. Next, we'll discuss deep learning, and my colleague Hima will continue from here onwards.
Thank you, Ayodhya. Now I'm going to discuss about deep learning. When dealing with high dimensional data sets, especially with the large data, the traditional learning methods are not useful. So deep learning algorithms are used. It is for the large tabular data sets. So many frameworks were developed. Some of them are Caffe, CNN architectures. Nowadays, deep learning is very popular and using in many business projects and research topics. The performance of the algorithm is based on the image data we use. If you use high quality photos, then the performance of the systems will be increased. These are some of the known image sets that used in this algorithm. They are CIFAR10, MNIST, ImageNet, and PVOC. The CIFAR10 data sets, there are 10 groups, and all images are 32-bit color images. Then all images are virtually handwritten in black and white in MNAST image set. ImageNet and PVOC are high resolution image datasets that are frequently applied in visual object detection and recognition. Benchmarking is used for checking the comparison with the existing standard, and it is very useful in the corporate sectors. And there are 7 principles in the benchmarking. And now we will discuss about that. The relevance, it is important factor should be measured via the benchmarks. The representativeness, the performance measure should be recognized by both the professional and corporate sectors. Equity, all the systems should be compared equally or honestly. And the next, repeatability. The results of the benchmark should be easily checkable, or we can check until meet the requirements. Cost effectiveness, the test of the benchmark should be in a reasonable cost. Scalability, the benchmark test should be done on a single server as well as a multiple servers. And transparency, benchmark criteria should be easy to understand. The computation power of hardware is based on the type of computation that is used. These are some of the non-hardware devices. They are GPUs and FPGA and ASICs. And coming to the GPUs, graphical processing units, the GPUs are globally hardware devices which is used in the deep learning. The performance of GPU is fast compared with the other hardware devices. In comparison to CPUs, GPUs perform at a kind of multitasking that is typically useful to AI algorithms, and thus are perfectly suited to AI applications. The second hardware device is FPGAs, which is field programmable gate arrays. FPGAs are flexible. They are designed to perform well on algorithms, but the drawback is the lack of the complex software layer required to fully recognize their AI potential. And then other hardware device is ASIC, which means the application specific integrated circuits. It is designed to use for the particular applications. The performance of this device is high compared with the GPU or CPU based on the research done by the Google. The technologies like CPUs, multiple cores, and hyper-threading have problems in the big data era. The deep learning models generally contains products and matrix rearrangements. So these algorithms need a lot of computational power. The deep learning algorithms can use high-speed shared memory to increase processing performance after copying data for the global memory. The performance of the GPUs, FGAs, and ASICs are better when compared with standard devices like CPUs because they contain multiple resources and on-chip memory. The new algorithms are being developed to increase computing performance. The GPU performance is increased by using the algorithms like two-Euclid's matrix, fast Fourier transform, and so on. The flow of data causes energy consumption. The FPGAs and ASICs devices have low energy on-chip memory. The algorithms like weight stationary data flow, no local reuse data flow can help to decrease the energy consumption and data movements. Thank you.